2 dead mini lathes. Mechanically, they are perfectly fine, but the electronics are busted. I decided to look online for a replacement. Hold on a second, I work designing motor drives. Surely I should be able to design one of my own, right? Well, as it turns out, I have a few ideas up my sleeve. Check this one out. Man, this is not gonna fly, we need high voltage. Ah, high voltage you say? Well, no problem. Here is a PAC5556 design which should be able to tackle this project beautifully. Ooh, PAC5556, huh? And what is so special about it? Glad you asked. The beauty behind the PAC5556 device is that it integrates everything that we need to drive our motor, but most importantly, it integrates a high voltage DC to DC switch mode converter which takes our high voltage and derives the 12 volt required to drive our United Silicon Carbide MOSFETs. Whoa, did you just say Silicon Carbide MOSFETs? Ooh yeah, Silicon Carbide MOSFETs. But doesn't Silicon Carbide MOSFET require specialized gate drivers? That is correct, but United Silicon Carbide MOSFETs were tuned so that they could be driven with conventional gate drivers like the ones on the PAC5556. Dude, what are we waiting for? Let's strap this puppy into the lathe and take it out for a spin. Okay, here we go. I have been able to package the PAC5556 reference design with silicon carbide MOSFET pretty good into this blue box. And the way that it works is that power, 120 volts AC, will come into this IAC connector. There is a switch, there are some fuses, and then the 120 volts AC are going to go into a board that you cannot see here. It's back there, but basically it's a rectifier, which is going to take the 120 volts AC and generate our 170 volts DC. It's rectified, so it's kind of noisy. That's why we have these big caps in here to filter the signal as much as possible. And then that 120 volts DC are going to be used to drive our three-phase inverter, although in this case I'm using a full H bridge. But it will also power the chip because the chip is going to take that 170 volts DC and generate the 12 volts or 15 volts that we need to drive the inverter as well as everything else. Okay, so what do we have here? I'm going to be using a graphical user interface to control the lathe. This is basically on prototype stage. But you're going to find similar controls of what you have on your lathe, like how to control the direction of rotation of the motor, or in this case, the chuck. The PWM, which is how you control the motor speed. And I'm going to try one thing here, which is how to regulate current. It's not working as well as I would have hoped, but it's a work in progress. All right, so let's take a look at PWM control. Basically, when you don't enable current PI or speed PI, you are on PWM control. So if I turn the lathe on now, it's going to go at that speed, which is directly proportional to the voltage that we're applying. Okay, so I'm going to increase my PWM. And this is like you would have with that potentiometer that the lathe comes with, okay? Very similar, you can control the speed of the chuck. The other thing I wanted to try was to control the motor current, which is basically a way of regulating torque. So what I'm going to do is I'm going to enable the current PI, which is a PI loop that is going to look at the current from the motor, and then it's going to try to regulate to something. Let's try 1.5 amps. Here's the command. And in here, you're going to be able to see what current the system is measuring. This is just the last measurement that it took. It's not the current right now. The current right now is 0 because the lathe is off. So let's turn it on. And you see that it's trying to go to 1.5. And that's basically the current the system is sensing. So let's go to 1.75. And as you can see, as I change the current command, the lathe changed the speed. But what is the speed? We're measuring the speed here, but you know, it is something, and it is such a complex system with all of the gears and stuff that is just really hard to control with the current. So I am not very happy with that at the moment. It's something that I need to look further. The last thing we could do would be to regulate the motor speed, in this case the chuck speed, but for that the current control needs to work first, because what I'm doing is that I'm using the output of the speed PI to control the current PI and the current PI to control the PWM. So until I fix the current regulation, the speed is not going to work very well. So that's part of the work in progress. But if I want it to work and whenever it's working, what I would do is enable the speed PI and then just do a speed command. It could be a 1000 RPM or 1250, 2000, any number you can think of, up to 2500, which is the maximum speed this lathe can do. But that part is not working yet, so I'm going to have to get back to you guys at a later time with that part of the project. Well, we could not have called this Mini Lathe Resurrection unless we had made some chips. So I'm happy to report that thanks to the PAC5556 and its ability to drive motors at high voltage, I was able to bring this lathe back into operation and make some chips. The project is basically in its infancy. I still have so many features to add, but you know, it's a work in progress. I do plan on continue to work on this project as time allows. I do want to thank you for tuning into my YouTube channel, and I'm going to see you on the next one.